Hi, in this video, we'll be focusing on Sentry for Android. Whereas other tools aren't made for developers, Sentry is really the only solution that helps developers see and solve application issues in record time. By providing all the details, context, and opinionated workflows, Sentry can increase developer productivity and accountability. Companies such as Nextdoor, Instacart, Cisco Meraki, Disney+, and Riot Games use Sentry to monitor their applications, be it mobile, consumer-facing front-ends, or back-end services. To get started with Sentry, you'll need to install the Sentry SDK into your application. We have SDKs for almost every programming language and framework. Once the SDK is installed and configured, errors, sessions, spans, and profiles will be sent up to Sentry accordingly. Today, we'll showcase Sentry in my team's Android app. To get started with Android, we recommend using Homebrew to brew, install, and run the Sentry wizard to install the Sentry SDK. Another option is to install the Sentry Android Gradle plugin manually. Either way, you can then initialize the SDK with our DSN, which is associated with your Sentry project. Here's a code snippet of minimal configuration to your Android manifest file with DSN, traces sample rate, profile sample rate, and time to full display. Now that Sentry is set up on my Android app, let's put ourselves in the shoes of the developer. We have two unrelated critical issues affecting the user experience. Sentry will help me see and solve both of them within 5 minutes without me having to go into a rabbit hole and ask questions. After solving these issues, we'll find some application level optimizations via Sentry's guided performance workflows. As a user, I'm opening the app and I'd like to buy a bunch of expensive plant products. The app isn't starting very quickly. We have no idea what's causing the slowdown. It could be on the application layer, device related, middle tier, backend, database, or any combination of these. As an ambitious plant hobbyist, I'd like to make a purchase, but I can't make any purchases after adding over $1,000 of plant products and our cart is not working and I'm trying to check out. This means we can't complete the purchases and the company's not taking in revenue. Since the developers are using Sentry, we can see that they're automatically notified of the errors in the mobile app, along with some performance problems. Let's start with debugging the checkout error. We've been notified of this error with some alert rules that have been configured. The backend API exception has been occurring since our latest release and is affecting users in production. We can see that across all the times this error has occurred, it's happening only in our production environment. Now, if needed, we can also create an issue within Jira or other project management platforms. This is surfaced as a high priority issue. Now let's examine a specific event for insight into what's happening. We can see specific attributes of the error as tags. A configurable set of highlighted tags are available here, and that's to help us understand the context of the problem. We also have the symbolicated readable stack trace to see the lines of code where the issue is occurring, along with other stack trace frames along the way. Sentry uses this to intelligently group errors to see the impact of each issue. We can also see that the code responsible for this error was not tested since it's highlighted in red in our integration with CodeCov. So in this case, we can see that the code has not been unit tested, and we should probably write a test alongside resolving this to avoid regressions in pre-production. We can also hop directly into GitHub or CodeCov from this stack trace. We have a replay available to see a snippet of the end user session and when the error occurred. The steps leading up to the error are documented as breadcrumbs. For this end user experience, we can see that the user clicked our action cart along with some of our logcat messages, which led to a 500 error. As I mentioned earlier, Sentry doesn't just help developers see issues in real time, it also helps them solve in record time. We can leverage AI to suggest a fix for the problem right here. In this case, Sentry AI tells us that the crash is likely on our process delivery item method. This includes a server-side request, and here's a better way of writing the code to account for these types of errors. Now we have all tags, a screenshot to show what the user was seeing at the time of the error, context with details about the user, app, and device, and we can also render a JSON representation of the view hierarchy at the time of the error. Any additional information specific to your app or end user device can be added as well. In addition to providing these granular details, Sentry integrates with source control management platforms like GitHub to surface the suspect commit and code owner. This integration can suggest the developer or team who have the most context and best chance of fixing the problem in the shortest time possible. With everything we've reviewed, we can confidently establish that the broken checkout flow is related to a problem in the backend. Sentry links errors across services so we can easily trace an error downstream with one click. I can quickly navigate from the Android error on the checkout process to the backend error on the checkout endpoint. From there, we can review the details and context from the backend perspective. Now that we understand what's wrong with our broken checkout experience, let's debug the slowdown from our app start. Sentry has notified us that we have both a slow database query and an N+1 API call that are causing slowdowns and should be addressed. So rather than just telling the developer that the screen is slow or an API endpoint is slow to respond, Sentry describes that the slowdown is due to a problematic pattern that needs to be fixed or optimized. Let's take a look at the N+1 API call. We can see that this N+1 issue has been happening very frequently, and Sentry has pointed out the problematic spans, specifically the repeating inefficient requests. Let's head to the transaction to understand the larger picture. We can once again see the N+1 issue. Optimizing those queries into a single query can help shave off maybe about a half a second. But looking a little bit deeper, we can see that product processing is taking about a second and a half and pushing out the time to full display. This is something we can optimize on the mobile team. Now this is as far as tracing can take us. We have identified the slow span, but we would need to instrument more to get further clarity. This is where profiling comes in. The developer can dive directly into the profile from a span in Sentry. With profiling, we're presented a flame graph that shows the call stack and timings associated with each function call. It looks like the getIterator function is recursing excessively, which needs to be addressed. Sentry helped me find exactly where and why the slowdowns are happening to resolve them in record time by pointing out known performance issues and allowing me to see the application frames in production. Sentry will also identify data sets of interest. Here we see suspect tags and functions likely contributing to the user-experienced slowdowns. We also associate related issues that have been happening within this UI load. In this case, Sentry has surfaced the specific span and functions we looked at previously. So far, we've responded to some issues where Sentry has flagged and alerted us. Let's use Sentry to get some insight into how long our Android app takes to launch. App Starts shows us data across releases on both cold start and warm start. Let's learn about why the app's cold start, which is when our app is launching for the first time, is so different between these two releases. By navigating to the screen, we can quickly identify the duration changes between the spans. Then we can easily find samples for a suspicious span between the two releases to drill into their profiles and see the function level details. Here we can see the check release application frame can be investigated. Similarly, we can use Sentry to find out what and where developers should optimize for a better and more performance user experience, and this is with the context of screens. We can use screen loads to identify slow or regress screens to understand the factors contributing to slow time to initial display and time to full display across releases. There's a notable difference in these metrics between our two latest releases. The screen summary has a series of widgets to show side-by-side data from a select 2 releases. We can use these graphs and tables to identify any anomalies. Between our releases, an anomaly is coming from a DB query. We can investigate this by finding occurrences of that span and reviewing samples of when they occurred, from a transaction or profiling perspective like we did before. Sentry has a variety of ways to surface slowdowns and take us to the code level culprit. For this screen, we have this application level frame showing my DB query function is slow with a contrived slow query function, and we can easily compare and contrast other profile samples to understand how our code is performing in production. Now that I've showcased how developers can use Sentry to respond to issues and find areas to optimize, let's talk about other ways to represent the application data sent to Sentry. Discover lets you quickly slice and dice data and create relevant alerts and dashboards. Let's break down the error count by different customer types and then set an alert for our enterprise customers experiencing errors in production. We can leverage the criteria we've set to create an alert. We can also add this criteria as a widget to a dashboard. Here's an example dashboard where we can see session health metrics, errors, and performance data all in one place and drill down as needed. And that's all I have to show you today. To recap, we were notified on specific issues from both error and performance, which we saw in real time and moved on to solving them in record time. We were able to find out precisely the root cause and the code responsible, along with the author who can quickly fix it. We were able to find out exactly why the app was slow, whether it was a problematic pattern such as an N+1 performance issue, or with profiling to see why specific code or functions were inefficient. We also identified poor cold start and time to initial display scores, guiding us to find specific areas to optimize. Lastly, we use Sentry to slice and dice data, see how to set up an alert, and visualize various data sets in a dashboard. In conclusion, Sentry aims to help developer productivity with an opinionated UI and workflow, enabling them to see and solve issues as efficiently as possible and improve application uptime and quality. Thank you.